Hi everyone, today we're learning about special right triangles. So there are two relationships to memorize here. The first one is called 45, 45, 90, and the second one is called 30, 60, 90. Right, so two triangles. What they're called is in relationship to their angles. Okay, so their angles, they always have that 90 degrees because we're dealing with right triangle trigonometry. They have a right angle. And then they have two angles that are the same for this one, 45 and 45, right? So 45 and 45. And since they have two congruent angles, that means that they also have two congruent sides. So both of their sides are the same, and then their radius is obviously longer. The relationship that they have is 1, 1, square root of 2. So essentially, if the x is 1, that means the y is also 1, and the radius is the square root of 2, right? You can expand this with similar triangles. So if this was 2 and 2, then this would be 2 root 3. If this was 3 and 3, you'd have 3 root 2, right? If you had like 13, you'd have 13 here in all of these places. All right, but the standard version is just 1, 1, square root of 2. Right, so 1, 1, square root of 2. The other triangle that we deal with is a 30, 60, 90 triangle. So it's a little extended here. So we have a 30 degree and a 60 degree in addition to our right angle. And this follows a like similar pattern in that the short side is always going to be 1. The radius will always be double it, right? So it'll be 2. And then the long side, right? So not the radius, not the hypotenuse here, but the like longer of the two sides is going to be the square root of 3. So essentially what we're saying here is like if this was a 4, then we would double it to get this one at 8. And if this was a 4, then we would multiply this, so it would be 4 root 3. So let's say, for example, we know that this is 4, this over here would be 8, and this would be 4 root 3. Right, so it all operates off of the short side. Let's say it was 10, then the long side would be double that, 20, and this side over here would be 10 times the square root of 3. Like that. So it always works in this order whenever we have a 30, 60, 90 triangle. Right, so our 30 degrees is going to be opposite of 1. Oops. Our 60 degrees is going to be opposite of square root of 3, and our 90 degrees is going to be opposite of the times 2. Like that. So these are going to be things that we want to memorize as we're moving through today, but we're going to see how they work using our signs within our unit circle. So for example 1 says, use special right triangles to find the trig function for the given angle. Draw and label the triangle and give all necessary information. So we're going to use these triangles that we were just talking about. These are called our special right triangles. And we're going to use them to figure out what sine 45 is or cosine 135. So the first step that I'm going to do is go ahead and label my ratio. Right, I'm going to label it. So, label the ratio. That's like saying, okay, since this is sine, I'm going to say this is y over r. Y over r. That's that first step. Okay. My second step is going to be to draw the triangle. Draw the triangle. So since this says 45 degrees, I know that that's halfway between 90. Goes up like this. I have my triangle. I know this is 45. That means this is also 45. Okay. Since I know that this is 45, 45, 90, I can label this as 1, 1, square root 2. Right? The relationship between them is 1, 1, and square root of 2. Okay. And then finally, my third step is going to be to write the ratio. So writing the fraction here, I want my y, which would be 1, over my radius, which is square root of 2. Right? Noticing, of course, I have to rationalize. So multiply by square root of 2 on top and bottom. It's going to leave me with square root of 2 over 2. This is my answer for sine 45 degrees. Those are my answer. So first thing we did was we labeled it, right? We said, okay, sine is y over r. My second step was to draw that triangle, right, using the 45 degrees, and then write the ratio, right? So that's what I did here. Okay. We'll go ahead and do cosine 135, right? So cosine 135 is halfway over here. It is counting, remember it's counting from your 0 here, so it's counting this like this, 35. But what that means is that my reference angle, that's this angle for my triangle, this part here, right? That's what's left over in order to get to 180. So that would be 45 degrees, right? So since that's 45 and 45 and 90, then we know we have the same relationship as in the first example. We have 1, 1, square root of 2. So we're able to quickly, basically the special right triangles are like things that we memorize, like tricks that we memorize in order to quickly be able to label a triangle, right? So cosine 135, want to make sure that this is -1, right? Be sure that you are marking your negatives still. We know cosine is x over r, right? So since it's x over r, we would have -1 over square root 2, right? Rationalization still, square root 2, square root 2. Negative square root 2 over 2. Just like that. Right? So this would be my final answer for this triangle here. All right. Go ahead and take a moment, try to work on tan of 225 and come back to me when you're ready. Pause the video. All right, so hopefully you're able to label that tangent is y over x, right? And since it's 225, it's going to be over here in this angle or in this quadrant. We have the 180 here and then the last 45 to get to 225. So we have a 45 degree angle, right? Since this is a 45, 45, I know it's 1, 1 square root of 2. So I want to make sure I put my negatives here since we're in the negative, negative quadrant. So we have -1 on our x, -1 on our y. So my y would be -1 over my x, -1. That would equal +1. So my negatives will cancel. That is my answer. You might be wondering, like, does it have to be 1 and 1? Like, no, it could be 8 and 8, -8 and 8, and then this would be 8 square root 2. Notice my answer, my ratio is still going to be the same because -8 divided by -8 is still going to give me 1. Right? So it could be any number that you want to use here, right? And then this would be that number times the square root of 2. But ultimately, when you create this, your 8s are still going to cancel and leave you with just 1. Right? This will happen every time. Even if it was like negative, let's say we got really fancy and used just like -x, then this would also be -x. And this would be x times the square root of 2. And you would have -x over -x, which still simplifies to +1. So no matter what numbers you put there, it'll still work out. All right, let's try one more example here. We're doing the cosecant of 315. Look back in your notes if you don't know what cosecant is, and then come back in just a second. Pause the video. Did you pause it? Sweet. All right, so cosecant is the reciprocal of sine. Sine is y over r, so this time we'll be looking for r over y. We're looking for 315 degrees. So remember that we measure it from here. So we went 90, 180, 270, all the way here. And that gave us 45 degrees, another 45, which means we have 45 degrees on this side here. So we went the 315 here, and then now we're at 45. That means that I have 45, 45, 90, which means that I have 1, 1 square root of 2. Make sure this one is negative. So my radius here is the square root of 2. My y is -1. It's going to go ahead and simplify to negative square root 2. That would be my answer. Sweet. So we've learned a lot about 45, 45, 90 triangles. Now we're going to take a look at the other subsection, which is our 30, 60, 90 triangles. All right. So we're going to follow the same steps. First step is to figure out what ratio I have. So secant is the opposite of cosine, right? Cosine is x over r. So this, what we're going to be looking for is r over x, the reciprocal version. All right. So now I need to draw my triangle. I have 60 degrees. So it's going to be like a little bit more up here, like 2/3 of the way, and draw straight down. This here is 60 degrees, right side angle. That means this is 30, right? So remember, across from the 30, the shortest angle is going to have the shortest side across from it. This would be 1. The radius is going to be 2. It's going to be double it. And this side over here, square root of 3. Quickly check for negatives. We're in the positive category or quadrant, so we're good. And then I need to do r over x. So r is 2 in this case. X is 1 in this case. Simplifies to +2. And that is my answer for this problem. All right, let's go ahead and look at cotangent 210. If you think you got the hang of it, feel free to pause the video. We'll do this one together. So I've got 180, that's there. So I already have 180, and that's going to leave me with 30 degrees left over. So I know that I have just 30 degrees, right? Not in the middle, that would be 45. Like this. I'm going to go straight up. This is going to give me 30 degrees here, 60 over here, and 90 there. So 30, opposite of that is going to be your short side 1. Opposite of that is going to be your longer side, square root of 3. Your radius always going to be 2. Think quickly about your negatives. -1 because you're on the negative side of the y, negative square root of 3 for your x's. And we should start with cotangent. So we want to find cotangent. Cotangent is the reciprocal of tangent. Tangent is y over x. So we need x over y in this case. So our x in this case is the negative square root of 3. The y in this case is -1. So we get square root of 3. That's our answer. All right. We're going to do 2 more. If you have a chance, you should pause the video, check it out. We're going to do sine 240 to start. Sine 240, start by drawing a triangle and labeling your side. Come back in just a second. All right, so sometimes the trickiest part is drawing the triangle. So I'd like to think of it in like 180. If it's more than 180, I think of it that way. So here's my 180, that first part. And then I have to know how much more do I have to go to get to 240. I'd go like 60 more to get to 240. Right, so I know this one is 60, which means this one has to be 30, along with my right angle there. So now that I know that portion there, I can know my side. So short side is always 1, long side always 2, in the middle square root of 3. Check your negatives, so -1, square root of 3. And then sine is y over r. Your y here is negative square root 3 over r is 2. Check to see if you can simplify. You can't. So this would be your answer. Nice. Okay, we have one more. I really want you to try it on your own if you haven't yet. Go ahead and pause your video. Try it on your own. All right, so we know cosecant is the reciprocal of sine, so we'd be looking for r over y. And then again, I think the hardest part is drawing the triangle. So if I think about the first 3 quadrants, that's 270 degrees. And then I have to go 60 more past that. So this blue angle here, that would represent 330 degrees. But when we draw our triangle, we're looking for the angle inside, right? So we're really saying like how much more do I have to go to get to this line, right? And that right there would be 30 more, right? That 360 minus the 330, that 30 left. So this would be your 60 and your 90. So across from 30, that would be your short side 1, long side 2, middle side square root of 3. Checking negatives, we got -1 here, positive square root of 3. So then you're looking for your r, which is 2, over your y, which is -1. And go ahead and simplify that into -2. That is your final answer. Okay. So all of this that we've been learning today, all of it is just a helpful way to get to our answer faster, right? So when we see that relationship, the 30, 60, 90, or if we see this relationship, the 45, 45, 90, we know that we can rely on these numbers here in order to help us find the trig functions faster. All right. Ask any questions that you have. Happy to answer them. Like, comment, and subscribe. See you later. Bye.